Hello, in this lecture we will continue on chapter 21 and we'll be discussing computing a multi-product break-even point. You remember we left off last time talking about a break-even point for a single unit of product. So therefore we were thinking about how many units we have to sell in order to break even, meaning that our sales equals our total costs. We're not making any money, we're not losing any money. That's the first step to calculate before thinking about how much we have to sell in order to achieve a particular amount of profit. But we can think of many situations, and of course where we have more than one product that we are selling, we may have different sales prices, may have different types of variable costs depending on the units that we are selling. Therefore, how can we come up with the same type of analysis to see what combination that we need to sell in order to achieve a similar break-even analysis so that we can think about this in a similar way? So we can convert the CVP formulas to adjust them for multiple products in this way. First, the unit contribution margin is replaced with a contribution margin for a composite unit. So remember what the contribution margin is per unit. We'll take the unit sales less the variable cost per unit. That would give us the unit contribution margin. We're going to just replace that with composite units. Once we do that, we could just do the same calculation we had for the break-even analysis for one unit as we do with multiple units by just replacing this composite unit with the normal units. So but then of course the question is, well, how do we come up with a composite unit? What is that consisting of? And it's going to be an estimate for the most part, an average of all the different units and different prices that we're going to have. We're going to have to sum those together in some way, come up with one unit that will represent a composite unit of all the types of products that we have. So a composite unit is composed of a specific number of each product in proportion to the product sales mix. And then what is the product sales mix? Well, the sales mix is the ratio of volumes of various products. So we're going to have to estimate the ratio of volumes that we are going to have and conduct an estimate in order to come up with the sales mix so that we can use it to create this composite unit. So once we have done that, then the calculation is very basic. It's the same calculation we had for one unit. We're just going to take the fixed cost, the stuff that doesn't change like the rent, divided by the contribution margin per composite unit. Remember, the contribution margin per unit is the sales price less the variable costs. The only difference now is that we have that calculation for these composite type units. So let's take a look at an example and try to think about, well, first, of course, how do we come up with this composite unit thing here? We have the hair today offers 3 cuts as shown below. Annual fixed costs are $192,000. Compute the break-even point in composite units and number of units for each haircut at the given sales mix. All right, so we have the basic cuts are $20 selling price, variable cost $13, and therefore we're walking away with $7 after each cut. In this case, after variable costs. Remember, variable costs could be, if we're the owner, it could be the cost that we pay hourly. If we pay the person who cuts the hair, that would go up at a constant rate possibly, or any kind of supplies within that area. We're walking away with $7 per haircut on the basic cut before we think about things like fixed costs being such as the rent. And the ultra cut, 32 and 18, we're walking away with 14 before thinking about the rent, and the budget, 16 and 8. So these are the 3 types of haircuts that we have. This is our contribution margin for each of them. Now we have our contribution margin ratio here, and this is a little bit deceiving because what we're really trying to think about is what is the ratio of cuts that we are going to have per type of product. So we're not really saying that we're going to sell 4 cuts here. What we're using is a ratio analysis. So the way to think about this is really we have 4, 2, and 1. That means that 4, 6, that adds up to 7. So therefore, if we took the 4 divided by the total, we're taking the 4 divided by 7, we have the 57. If we took the 2 divided by the total, we take 2 divided by 7, we're taking the 28. And if we take the 1 divided by the total, 1 over 7, we'd get the 14. If we added those 3, in this case decimals or percentages up, it would come up to 1 or 100%. We're thinking about the ratio. Now, you could think about the ratio in more basic terms as, like a percentage, like a 30-30 whatever type of percent, but the problem with that is that it may not be as exact. So when we think about a mix like this, you can see that obviously we do not have even distributions. We don't have even numbers. And if we think about a ratio in terms of this format, then we can calculate a ratio in a more precise way. A ratio is more precise than a decimal that repeats, that we're going to cut off at a certain point. So that's what we're thinking about here. So it could be a little bit deceiving. We're going to do a calculation as if kind of we're multiplying times 4 haircuts. But remember, what we're really doing is a ratio analysis. So then if we do this, then we're going to take the selling price, in this case, times the 4, which is our ratio analysis. We're doing a ratio here, and that would give us $80. And we're going to do the same thing for the 32 times the 2, the 16 times the 1. That would give us a selling price per composite unit, in this case, of $160. And then if we did the same thing for our variable costs, we're taking the 13 times the 4, gives us the 52, the 18 times the 2, gives us the 36, and the 8 and the 1 gives us the $8. That would be the variable cost. Therefore, if we think about our composite contribution margin, we have the selling price of 180 minus the 96 will give us our 64. So our composite unit now is 64. So then if we just take that 64 and divide it into our fixed costs, so fixed costs, the cost like the rent divided by our composite unit that we just came up with of 64, then we come up with 3,000 composite units. Now, what does that 3,000 composite units mean, you might be asking? 3,000 composite units, how many cuts do I have to have of the basic? How many do I have to have of the ultra and whatnot through that 3,000 composite unit? We would then, because this is just an estimate and it's a ratio in that estimate, we would then have to multiply, such as this table, and take our sales mix. Remember the basic we said was 4, 2, and 7. 4, 2, and 1, which adds up to the total 7 of the sales mix. So we have 4 sevenths, 2 sevenths, 1 seventh. And if we multiply it times our composite unit number that we just came out with, that 3,000 means that the mix of that 3,000 needs to be in the ratio of the 4, 2, 1, which adds up to, the 7 here. So that means that we have the 3,000 times the 4 gives us the 12. The 3,000 times the 2 gives us the 600 of the ultra, and the 3,000 times the 1 gives us the 3,000. That adds up to 21. And then just so you can see that we kind of backed into our ratio analysis here, if we take a look at that total of 21 and we multiply it times the 4 over 7, if we take, we got the 21,000 times the ratio of 4 sevenths times 4 divided by 7, that means we have the 12,000. So that's why we backed into this ratio analysis. So in similar fashion, if we took the 21,000 times the 2 over 7, so times 2 divided by, 21,000 times 2 equals divided by 7, that will give us the 6,000. And then for the last item, it would be the 21,000 times 1, which is of course 21,000, over the 7, which would be the 3,000. So that's how we're coming up with this ratio analysis. So if we were to prove that, then we could do the proof here and say, well, if we sold 12,000 at $20, we'd come up with the 120. If we sold the Ultra 6,000 at 32, we come up with the 192. The budget 3,000 at 16, we come up with the 48,000. Those three add up to the 480. The variable cost, we have the 12,000 times 13, or the 165. The 6,000 times the 18, or the 108. And the budget is 3,000 times the 8, gives us the variable cost in this ratio. That adds up to a total. These three add up to a total of 288. And then if we subtract these out, this column 240 minus the 156 is the 84, and so on. And this column adds up here, and you can see that that equals our fixed cost.